So we're focusing on acid-base chemistry of the amino acids right now. And as a quick review, right, Bronsted-Lowry acid-base chemistry. So in this system, we have acids as proton donors or hydrogen donors. So in the Bronsted-Lowry system, acids donate hydrogen to solution, and these lower pH of the solution. Bases remove hydrogens from solution, and these will raise the pH of the solution. And so that's the deal. Let's look at the reaction mechanism and products for the autolysis of water. So autolysis or autolysis, either way, both are fine to use. The deal here is that we have the self-splitting of water. And we tend to think of the self-splitting of water as happening, in this way, but it's not exactly what's happening in reality. What's happening in reality becomes more clear when we look at the mechanism and what's going on. So we have a water molecule there, and we have a water molecule here, and you'll see that this is self-splitting of water. It's not just one water molecule, but it's water as a population. So if we add these two water molecules together, you will see that we can have the electrons here rob away that hydrogen, and then the electrons from this bond fall back to the oxygen, and this is a reversible reaction. What we end up with then is this, where we have an oxygen with 3 hydrogens, and this will be, our hydronium ion. And then we have, these electrons fall back to this oxygen, and we have a hydroxyl. Okay, so that's got a negative. I will draw you the quick reverse of this reaction. So here we've got your hydroxyl plus the hydronium here. And in this case, these electrons are going to rob away a hydrogen from this molecule, and the electrons will then fall back to that oxygen, and we're going to end up with your waters again. I'm just writing it this way to get through with this. Oh, I almost forgot. What exactly is pH? Well, this is important. We better define this because that's our focus right now. pH is a measure of acidity, and pH is the negative log of the hydrogen ion concentration of a solution. All right, now where you see a P like this, like little p is a mathematical function, and whenever you see little p with something after it, little p always means take the negative log of whatever that item is. So negative log of whatever that variable is. So little p is a mathematical function. So pH in solution is a negative log of the hydrogen ion concentration, and this is really important because pH, the pH scale, is a logarithmic scale, and this is really log base 10 scale. So if we undo a logarithmic value and it's a log base 10, we are actually going to be returning what would be the exponent, to the 10th power. So what does that mean? I'll write it this way for you. If we have a pH of a solution equal to 5, it means that there is hydrogen ion concentration of 1 times 10 to the negative fifth molar. And so this hydrogen ion concentration on the pH scale, it's very important that you always use units of M, capital M, which is molarity. And just to refresh your minds, molarity is moles per liter. So watch your units as you're working in the pH scale. Some more examples for you here, just really quickly. If we're talking about a hydrogen ion concentration of 1 times 10 to the minus eighth molar, then the pH of the solution is going to be equal to 8, because 8 is the exponent, and if we take the log base 10 of this number, 1 times 10 to the minus eighth, we are going to get back a minus 8, and because the pH function is to take the negative log, we have essentially a minus 1 times that minus 8, and we get an 8. So you can review your mathematics here.